Hey, hello, what's up, guys? This is Yassa with another video, and in this video, we're gonna talk about nitration of benzene. Okay, so let's start with the benzene. Okay, first of all, I would like to write the general reaction. So let's start with the first general reaction. I'll be using the short form, that is GR. Okay, this is our benzene, which is reacted with mixture of concentrated H2SO4 and plus concentrated HNO3, which gives NO2 along with benzene, and this product is called as nitrobenzene. Okay, so just write me. So this particular compound is called as nitrobenzene. Okay, so this is the nitrobenzene. Let's see how the mechanism works out. We should not be bothered about the byproducts which are coming out here over here. Okay, so let's start with the mechanism part of this one, because byproducts are not important. Okay, so let's start with the mechanism. Actually, the reaction takes place in three steps. So we'll talk about the first step, and that is nothing but called as formation of electrophile. Okay, the first step is formation of electrophile. Now question comes, what is electrophile? So let me tell you the important aspect of electrophile. Electrophile is nothing but the species which is electron deficient, electron and deficient, and which has huge attraction for electrons, or simply you can say which is in love with electron. Such species are called as electrophile. So let's start with the reaction. So this is H2SO4. Let me draw the structure. And we know that each oxygen atom is having two lone pair. Okay, now there is another acid called as nitric acid. Okay, so this is the structure of nitric acid, and we know that among nitric acid and sulfuric acid is the strongest acid, so it will just lose its proton. Okay, and which is being transferred to the oxygen of this nitric acid. So proton from here will go to the oxygen. Okay, we have to always show the arrow from a positive to negative. Okay, so further what happens, there is a release of water molecule from nitric acid, and we'll be having HSO4 minus plus H2O plus NO2. This is called as nitronium ion. Okay, nitronium ion, and nitronium ion is the electrophile over here. Okay, so let's move towards the second step, and that is nothing but the attack of electrophile. So the second step is attack of electrophile. Okay, so in this, the nitronium ion attacks over the benzene ring. So let's see. So let me draw the structure of benzene ring. So this is the benzene. Okay, and here is the hydrogen atom. Okay, and this is NO2 plus. Okay, NO2 plus directly attacks to the benzene ring, and then we are having this particular intermediate. This is Na2 and this is H. Okay, and this carbon gets a positive charge. Now, because among these two carbon, the first one is kept by the carbon to which nitronium group is coming, and this one, the second one, I just show it with the red color, is being transferred to nitronium group. That's what this particular carbon gets a positive charge. Okay, this whole positive charge is distributed in the ring completely. Okay, so let me just change it. So this positive charge undergoes resonance, we know that. Okay, then this is being transferred over here, and finally we are having an resonating structure which is called as sigma complex. Let me draw the structure. So this whole part gets a positive charge, and here it is H, and this is NO2. But the carbon which is shown with the red color does not have the positive charge. Okay, this particular intermediate is called as sigma complex, or it is also called as VLAND complex. VLAND is the name of the scientist. So this is the second step. Okay, I'll just tell you something about the property of this intermediate. This intermediate is having a positive charge which is stabilized by resonance, and it has lost its aromaticity. It has lost its aromaticity, and in order to gain the aromaticity it can lose the proton very easily. Okay, so this is the important point with respect to the intermediate. Okay, we'll move towards the third step, that is nothing but the removal of protons. So let's proceed towards that one. So our third step is removal of proton. Okay, so in this step what happens, the intermediate, that sigma complex, loses the proton in order to regain its aromaticity. Okay, and this is the whole positive charge. Okay, so it just loses the proton, and it is generally taken by the weak base HSO4 minus. Okay, so let me show you, it is being transferred to this one. Okay, and finally we are having this electron get transferred to the ring, and we get our aromaticity of benzene ring once again, and this is finally the formation of NO2 plus H2SO. Okay, so this is the mechanism of the nitration reaction. So I'll just tell you the important point with respect to nitration. Okay, the most important one is first the nitrating mixture. Okay, nitrating mixture which is required in order to generate the electrophile. So in this case the nitrating mixture is concentrated HNO3 plus concentrated H2SO4. Okay, so this is the first reagent that we require. Other than this, we can also do this particular reaction with the help of N2O5, yes, which is called as nitrogen pentaoxide. okay, which is having this type of structure, NO2 plus NO3 minus, which is called as nitronium nitrate. Okay, this is called as nitronium nitrate, or this reaction can also be done in presence of nitronium acetate. Okay, this is called as nitronium acetate. Okay, so this is about the nitration reaction. Let's talk about the energy profile diagram of this reaction. So let's move towards that one. So in order to draw the energy profile diagram, we'll be having our two axes. This one is x-axis, which represents a reaction coordinate. You can also call it as an progress of reaction. And here we'll be having our potential energy. Okay, and the graph will be somewhat like this. Okay, so you can see there are actually two TS. This one is the first one and this one is the second one, and this particular point represents the reaction intermediate. This is our reactant, that is nothing but the benzene ring, along with our nitrating mixture, that is our electrophile NO2. Now in this transition state, what happens? The hydrogen is attached and the nitronium ion is approaching the benzene ring. Okay, in this intermediate, there is a formation of intermediate. Let me draw. So the ring is having, let me draw a better diagram of this one. So here, the ring is having a positive charge and there is the NO2 group, okay, along with hydrogen. Now in the second transition state, what happens? The hydrogen is leaving the benzene and NO2 group is attached to it. Okay, NO2 group is attached to it, and this is our benzene. You can see the final product over here. It's nothing but the NO2 group. Okay, and you know that towards the left hand side we are having our reactant. So this is the energy of reactant and this is the energy of product, and the difference is called as delta H. So you can find out there is an energy difference, or you can see the energy of product is lesser compared to energy of reactant. So we can call this reaction as an exothermic reaction. Okay, let's talk about the rate determining step in this particular reaction. In this reaction, the rate determining step is the attack of nitronium ion. Attack of nitronium ion, that is NO2 plus. Okay, now this reaction is independent of isotopic effect. Okay, it is independent of isotopic effect. Now you'd be thinking, what is the isotopic effect? So I'll be just making a different video. In that I'll be talking about the isotopic effect on all type of reaction, that is sulfonation, halogenation, nitration, Friedel-Crafts reaction, all this. Okay, so don't worry about it. Just keep one thing in your mind, that nitration reaction is independent of isotopic effect. I hope you understood the video thoroughly. Okay, please press the bell icon so that whenever I'm making a video, you'll be getting notified. Okay, and please subscribe my channel. Thanks a lot for watching.